Good morning, dear children. Welcome back to our online math class. Okay, nowadays we have been discussing about the lesson factors and multiples, isn't it? In that we have learned the concepts of factors, multiples, prime numbers, composite numbers, isn't it? Unique number. Do you remember? Have you learned all those things? Yes, good. And finally we have learned the divisibility rules, isn't it? We have learned the divisibility rules. I think we have done exercise up to exercise 6b. We have completed exercise 6b, isn't it? Today let's try to do exercise 6c. Okay, try to do exercise 6c. As I have been saying always, before start writing, mention date and day on the upper portion. Okay, exercise upper portion of your margin. Okay, exercise 6c. Exercise 6c. First question. Encircle the prime numbers. Encircle the prime numbers. That's all. That's enough. Encircle the prime numbers. Encircle the prime numbers. That is the question. Encircle the prime numbers. Some numbers would be given. From that, what we have to do? Yes, we have to encircle the prime numbers. Do you remember what is meant by prime number? What is meant by what is the definition of a prime number? Yes, a prime number means a number with only two factors, isn't it? A number having only two factors is known as a prime number. A number with only two factors is known as a prime number. Okay, which are the two factors of a prime number? Can you say the answer? Which are the two factors of a prime number? Yes, first factor is 1 and the other factor is, yes, the number itself, and the other factor is number itself. Such numbers are known as prime numbers, isn't it? And we have written the prime numbers between 1 and 100. Have you written neatly that? Have you written that neatly? Yes, and I think most of you have learned that well also. You should know the prime numbers between 1 and 100 by heart for learning the problems in your higher classes. Okay, yes. Now let's try to write the given numbers. The given numbers are 5, 10, 7, 18, 1, 2. So among the given numbers, what we have to do? We have to encircle the prime numbers. Okay, let's check one by one. Is 5 a prime number? Yes, we know 5 has only two factors. 5 is equal to 1 into 5 only. 5 can be written as 1 into 5 only. So, can you find any other factor for 5? No. So, what can be concluded? Yes, 5 is a prime number. So, we have to encircle. Okay, if you want to do such calculations, you please do such calculations in your working column. Now consider the next number 10. Which are the factors of 10? Of course, we can write 10 as 1 into 10. Anything else? Yes, 2 5s are 10. So, is 10 a prime number? No. Why? 10 has how many factors? 1, 2, 3, 4. More than 2 factors are there for 10. More than 2 factors means 10 is not a prime number. So, we need not encircle this. Okay, what about 7? Is 7 a prime number? If you know that prime numbers between 1 and 100 without any doubt, you could do this easily. If those who haven't done that should try to do like this in the working column. Okay. What about 7? Which are the factors of 7? Of course, we know any number can be written as 1 into that number. Like that, 7 also can be written as 7 into that number. Can you find any other factor for 7? No, 7 cannot be written as the product of any other numbers than 1 and 7. So, only two factors. So, that means 7 is a, yes, 7 is a prime number, means we have to encircle, isn't it? Okay, now consider the next number 18. What about 18? Is 18 a prime number? So, which are the factors of 18? 18 can be written as surely 1 into 18. Anything else? Is 18 in 2 stable? Yes, 2 9s are 18. Is 18 in 3 stable? Yes, 3 6 are 18. Anything else? Is 18 in 4 stable? No. 5 stable? No. 6 stable? Yes, 6 stable. 6 3s are 18, 6 3s are 18 and 3 6 are 18, both are same. So by checking like this, we could finalize that 18 has how many factors? 1, 2, 3, 4, 5, 6. Isn't it? 18 has 6 factors. That means surely 18 has more than 2 factors. Surely 18 has more than 2 factors. That means is 18 a prime number? Not at all. Why? A prime number has 2 and only 2 factors. So 18 is not at all a prime number. So we need not encircle 18. Is it clear? What about 1? Is 1 a prime number? 1 has how many factors? We have learned earlier, 1 is not neither a prime number nor a composite number. 1 is a unique number. Why? 1 is neither a prime number nor a composite number. It is a unique number. Why? 1 has only one factor. 1 and only one factor 1. So 1 is not a prime number. 1 is not a composite number. It is a unique number. So can we encircle 1? No, we need to encircle only the prime numbers here. But 1 is not a prime number, so we need not encircle 1. What about 2? 2 has how many factors? 2 has how many factors? Yes, 2 has only 2 factors, 1 and 2. So 2 is a prime number and 2 is the smallest prime number. 2 is a prime number and 2 is the smallest prime number. That we have learned earlier. So do we need to encircle 2? Yes, we need to encircle 2. So which are the prime numbers? Among the given numbers 5, 7 and 2 only are the prime numbers. Have you understood? Yes. Now let's try to do the question B. If you are thorough with the prime numbers between 1 and 100, you could easily answer such questions. Okay. Question number B. Underline the composite numbers. Question number B, no. Question number 2. The second question is underline the composite numbers. Underline the composite numbers. Second question is underline the composite numbers. Okay, the given numbers are 15, 3, 9, 3, 9, 6, 11, 21. These are the given numbers. Okay, these are the given numbers. What is meant by composite numbers? What is meant by composite number? Meant by a composite number, a number having more than 2 factors are known as a composite number. A number with more than 2 factors is known as a composite number. So let's check one by one. Okay, here also let me say frankly, if you are thorough with the prime numbers between 1 and 100, it would be very easy for you. Okay. So let's consider 15. What about 15? Is 15 a composite number? How to check? Which are the factors of 15? Surely we can write 15 as, surely 15 can be written as 1 into 15. Okay, that's okay. What about other factors? Yes, 3 5s are 15. Anything else? No, this much only is there. So 15 has how many factors? Yes, 4 factors. That means surely 15 has more than 2 factors. So it is a, yes, composite number. Do we need to encircle 15? No, underline 15 here. Yes, why? 15 is a composite number, so we need to underline it. Okay, now consider 3. What about 3? 3 has 2 factors, 1 into 3. Anything else? No, this much only. So is 3 a composite number? Is 3 a composite number? Not at all. Why? 3 has only 2 factors, so 3 is a prime number. So do we need to underline 3 here? No, isn't it? Now consider the next number 9. Which are the factors of 9? Surely we can write 9 is equal to 1 into 9. Anything else? Yes, 9 can be written as 3 into 3. 3 3s are 9. So what about 9? Yes, 9 has how many factors? Yes, 9 has 4 factors here. 1, 2, 3, 4. So more than 2 factors. 4 factors means we can say 9 has more than 2 factors. So since 9 has more than 2 factors, what can be concluded? Yes, 9 is a prime number or composite number? Yes, 9 is a composite number. So what to do? Do we need to underline? Yes, isn't it? 9 is a composite number. Now consider the next number 6. Consider the next number 6. What about 6? Which are the factors of 6? Of course, as all numbers, 6 also can be written as 1 into 6. Yes. Anything else? Can you find any other factors for 6? Is 6 in 2's table? Yes. 2 3s are 6. Okay, this much only are there. Okay, if you want, you can verify. Can you find any other factor for 6? No. So 6 has how many factors? 1, 2, 3, 4. How many factors are there for 6? Yes, 6 has 4 factors. Isn't it? 6 has 4 factors. That means what? More than 2 factors. So more than 2 factors means is 6 a prime number or a composite number? Yes, since it has more than 2 factors, it is a composite number. So do we need to underline? Yes, yes, isn't it? Now consider next number 11. What about 11? Surely 11 can be written as 1 into 11. Can you find any other factors for 11? Is 11 in any other tables? Can you find 11 in any of the tables? No, 11 has only 2 factors. That means 11 is a, yes, 11 is a prime number. So do we need to underline 11 here? No, why? We need to underline the composite numbers only. But 11 is a prime number, so we need not underline it. Okay, now next consider, yes, coming number 21. What about 21? What about 21? How many factors are there for 21? 21 can be written as 1 into 21. That's okay. Then what about the other factors of 21? Is 21 in 2's table? No. 3's table? Yes. 3 7s are 21. 3 7s are 21. This much only. Okay. 21 also has how many factors? Yes. 21 has 4 factors. So what about it? Is it a prime number or a composite number? 21 has 4 factors. That means 21 has more than 2 factors. That means 21 is a prime number or composite number? Yes, composite number. So do we need to underline? Yes, we have to underline 21. So these are the required composite numbers. Have you understood? Got it? Okay, now write down the question number 3. Encircle the numbers which are divisible by 2. Yesterday I have given this question and most of you have sent the answer also. Good. Okay. Yes. Question number 3. Encircle the numbers which are divisible by 2. Encircle the numbers which are divisible. Encircle the numbers which are divisible by 2. Okay. For doing this, we should know the rule of divisibility by 2. What is the rule of divisibility by 2? What is the rule of divisibility by 2? Yes, a given number is divisible by 2 if its last digit is, yes, 0 or an even number, isn't it? This is the rule of divisibility by 2. What is the rule of divisibility by 2? A given number is divisible by 2 if its last digit is either 0 or an even number. So such numbers only would be divisible by 2. Such numbers only would be divisible by 2. So let's write down the question. The given numbers are 3,14,512, 65,301, 4,418, 29, 306, 7,888, 500, 441. These are the given numbers. So among these numbers we have to encircle the numbers which are divisible by 2. So for doing this, what we need to do? Yes, we have to just check the last digit, and if the last digit is 0 or an even number, without any doubt we can say that the given number is divisible by 2. We need to consider only the last digit, isn't it? We need to consider the last digit only. So let's check one by one. The first number is 3,14,512. Here, which is the last digit? 2. Isn't it? Is 2 an even number? Of course, 2 is an even number. So is this number divisible by 2? Yes, the given number is divisible by 2, means we need to encircle this one. Understood? Okay, what about next number? Coming number is 65,301. So for checking the divisibility by 2, we need to consider the last digit only, isn't it? We need to consider only the last digit. Here the last digit is what? Yes, last digit is 1. Is 1 an even number? No, we all know 1 is an odd number. That means this number is not divisible by 2, means we need not encircle the second number. What about the third number? The third number is 4,418. For checking the divisibility by 2, we need to consider only the last digit, isn't it? What is the last digit here? Last digit is 8. Is 8 an even number? Yes, we all know 8 is an even number. So what to do? Yes, so we can encircle this, divisible by 2, isn't it? What about the coming number 29? Here we need to consider the last digit only. Which is the last digit here? Last digit here is 9. What about 9? Is 9 an even number? No, 9 is not an even number. So what can be concluded from this? Yes, what can be concluded? Yes, we can't, 29 is not divisible by 2. So we need not encircle this number. What about the next number 306? Last digit here is what? Last digit is 6. Is 6 an even number? Yes, 6 is 6. Without any doubt, we can say 6 is an even number. So from this, what can be concluded? The given number 306 is divisible or not divisible by 2? Yes, given number 306 is divisible by 2. That means we need to encircle this one. Okay. The coming numbers, what is the next number? 7,888. In this, which is the last digit? Yes, 8 is the last digit. Is 8 an even number? Yes, 8 is an even number. So what can be concluded, or what can we say? Yes, we can say that the given number is divisible by 2. Why? The last digit is an even number. So we have to encircle this one. Isn't it? Next number is what? 500. What about 500? Here, which is the last digit? Yes, last digit is 0. So if the last digit is 0, the given number is divisible or not divisible by 2? Yes, if the last digit is 0, the given number is divisible by 2. So do we need to encircle this? Yes, we need to encircle this. Okay. What about 441? Here, which is the last digit? Last digit is 1. Is 1 an even number? No, 1 is not an even number. So what can be concluded from this? Yes, from this we can conclude that the given number 441 is not divisible by 2. So do we need to encircle? Not at all. Okay. So this is the answer of the given question. Have you understood how to do this? Okay, good. Now write down question number 4. Check whether the given numbers are divisible by 3 or not. Fourth question is check whether, question number 4, write down, check whether the given numbers are, check whether the given numbers are, check whether the given numbers are divisible by 3 or not. So some numbers will be given here. We have to check whether these numbers are divisible by 3 or not. Do you remember the rule of divisibility by 3? What is the rule of divisibility by 3? What is the rule of divisibility by 3? Who can say the answer? Yes, a given number is What is the rule of divisibility by 3? What is the rule? Yes, a given number is divisible by 3 if, yes, the sum of its done, right? If the sum of its digits is divisible by 3. A given number is divisible by 3 if the sum of its digits is divisible by 3. That is the rule of divisibility by 3, isn't it? That is the rule of divisibility by 3. So let's try to do one by one. Okay. Write down the questions. First question is 316. The question is 316. So how to find out this answer? How to check whether it is divisible by 3 or not? What we have to do? Yes, find out the sum of the digits, isn't it? Sum of the digits. Sum of the digits. What is the sum of the digits? Which are the digits of the number 316? Which are the digits of the given number 316? Which are they? 3 plus 1 plus 6. What is it? 3 plus 1? 4. 4 plus 6? 10. 10 is the sum. Is 10 divisible by 3? Is 10 in 3 stable? No. 10 is not divisible by 3. So, since 10 is not divisible by 3, we can say that, yes, given number is also not divisible. So, in simple words, we could write, since 10 is not divisible by 3, since 10 is not divisible, this is divisible. Okay, you please write properly. Since 10 is not divisible by 3, what can we say? Yes, 316 is also not divisible, isn't it? By 3. 316 is also not divisible. 316 is also not divisible. Okay, this is the first question. And now let's move on to the second question. Question number B. Write down the question is, so what we have to do for finding out whether it is divisible by 3 or not? Just find out the sum of the digits. Okay, if the sum is divisible, we can say that given number is also divisible. Okay, question number B is 429. So here also what we have to find out? Yes, sum. Sum of the digits is equal to sum of the digits. What is the sum of the digits? What is the sum? Which are the digits of this number? 4, 2 and 9. So sum is equal to 4 plus, sum is equal to 4 plus 2 plus 9. 4 plus 2, 6. 6 plus 9, 15. Okay. What about 15? Is 15 divisible by 3 or is 15 in 3 stable? Yes, we all know 15 is in 3 stable. So what can we say? Yes, since 15 is divisible by 3, the given number 429 is also divisible by 3. Or simply we can write, since 15 is divisible by 3, 429 is also divisible by 3. That's enough. Okay. While doing the examples, I have told you that. Once you are familiar with the concept, we could reduce the sentence, isn't it? Sentences. I have told you. Do you remember? Yes. So we can conclude that since 15 is divisible by 3, since 15 is divisible by 3, since 15 is divisible by 3, what is the given number? Yes, 429 is also divisible. 429 is also divisible by 3. Okay, now write down C. C, the question is, write down 8211. 8211. Answer. Here also what we have to do? Yes, we have to find the sum of the digits. So we have to find the sum of the digits. Which are the digits of the given number? Which are the digits of the given number? Which are they? 8, 2, 1 and 1, isn't it? So sum means 8 plus 2 plus 1 plus 1. What is 8 plus 2? 10. 10 plus 1, 11. 11 plus 1, 12. Is 12 divisible by 3 or is 12 in 3's table? Yes, we know 3 4s are 12. So 12 is in 3's table. That means 12 is divisible by 3. So from this, what can be concluded? Yes, since 12 is divisible by 3, we can say that the given number 8211 is also divisible by 3, isn't it? Write down. Since 12 is divisible, 12 is divisible, since 12 is divisible by 3, since 12 is divisible, 1 minute, let me write it properly. Divisible, you please write properly. Okay, by 3. What, which is our given number? Yeah, 8211 is also yes, divisible by 3. Divisible by 3 is also divisible by 3. Divisible by 3 is also divisible by 3. Got it? Okay. Now we have done up to C. Next question. Question number D. Write down. Very easy, isn't it? Just seeing it's or if you when you by practice you could be do this addition in mind, and without any further steps we could on just seeing the number itself you would be able to say whether the given number is divisible by 3 or not. Okay, now for the exams you have to write the step. This year for the exam you have to write the steps. When we learn the concepts of LCM, SCF and all, these can be done in mind. Okay, write down the next number 1002. Answer. What we have to do? Yes, we have to find the sum of the digits. Sum of the digits is equal to, which are the digits of the given number? 1002. So 1 plus 0 means no need to add 0. Okay, 1 plus 0 plus 0, no need to add 1 plus 2. What is 1 plus 2? 3. Is 3 divisible by 3? Of course, 3 is in 3's table. 3 ones are 3. So what can we say? Yes, the given number 1002 is also divisible by 3, isn't it? Okay, write down. Since 3 is divisible by 3, since 3 is divisible, since 3 is divisible by 3, yes, which is our given number 1002 is also divisible by 3, isn't it? 1002 is also divisible by 3. Very easy, isn't it? Just find out the sum of the digits, the same, and if the sum is divisible, we can say that the given number is also divisible by 3. Okay, write down E. Write down E. The question is 718. Question is 718. So how to find out? Yes, here also we have to find out the sum of the digits. The rule of divisibility by one more number is also the same. Find out the sum and the answer is divisible by that particular number. We can say that the question is also divisible by the given number. Which number's divisibility rule is similar to that of 3? Do remember which number's rule of divisibility is same as that of 3? What is it? Yes, it is 9, isn't it? The rule of divisibility by 9 is also the same as that of the rule of divisibility by 3. Why? The rule of divisibility by 9 is a given number is divisible by 9 if the sum of its digits is divisible by 9, isn't it? 3 and 9 have the same or similar divisibility rules. Okay, yes, let's find out the sum of the digits here. Sum of the digits is equal to, which are the digits? Yes, 7, 1 and 8. So 7 plus 1 plus 8. That's equal to 7 plus 1, 8. 8 plus 8, 16. Is 16 divisible by 3? Is 16 in 3 stable? No, 16 is not in 3 stable. So what can we conclude from this? Yes, since 16 is not divisible by 3, we can say that the given number 718 is also not divisible by 3, isn't it? So, please write down, since 16 is not divisible by 3, 16 is not divisible, since 16 is not divisible by 3, 718 is also not divisible. 718 is also not divisible by 3. Is also not divisible by 3. Got it? Okay. Now, note down the homeworks of this session. Note down the homeworks of this session. F, G, H are homeworks. The homework is F homework. The question is 1233. G homework. G, the question is 1233 is F. Let me write it once again. 1233. G, the question is 924. G also homework. H also homework. The question is H. Write down please. 512. 512. This is also homework. Okay, try to do today itself. This exercise will be continued in our coming class. Thank you. Have a nice day.